f of x over g of x, and that's equal to x cubed over x plus 6. And I'm just going to leave it in this form. That's no problem. So this is our final answer. But I'm going to push you guys to think about this a little bit more, because last week we talked about limitations on functions. And just a few minutes ago, I also talked about limitations on the function g here. Okay, g of x, it's in the denominator, so we know it can't equal a specific value, and that value, of course, is 0. So here we know that the denominator, g of x, that is this x plus 6, cannot equal 0. It can't equal 0. So if I were to plot this function, what can this function, or what can x never equal in the form that it's in right now? So there are really two ways that you can do this. You can either go to the Desmos app, which I want all of you to do. Go to the Desmos app and plot this function and see if you see any crazy features about the function. That is, any places where the function can get really, 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 really close to, but never actually equal. So do that first, and then raise your hand and have me come over and check your function and talk to you about it before you go on to the next slide. So hopefully after you plotted your function in Desmos, you saw that the function would get really, really, really close to -6. It would never actually touch -6. It looked like it did, but it just gets really close. It doesn't actually reach -6. And the reason why is because the whole denominator can never equal 0. So what we could do here to solve for those limitations, let's take the denominator, let's set it equal to 0, and we can solve for the x value that it can never equal. So that's a bit confusing. But basically what we're doing is we're solving for what x can never equal by setting it equal to 0. So x plus 6 is equal to 0. So again, just to clarify what this is saying, we're going to use this expression to solve for the value that x can never equal. And of course we just subtract 6 from both sides, and that was fairly easy, and it says x is equal to -6. So what this says is when x is equal to -6, the denominator is equal to 0. And we have a limitation. G of x, that is x plus 6, can never equal 0, so x can never equal -6. That's why you have those crazy curves that get really, really close to -6, but never actually equal -6. Now the final topic that I want to cover in this educated video is just plugging functions into other functions, which some of you said that you really wanted more practice with this. So I'm just going to stop here. Okay, I'm going to stop here. I'm going to say, evaluate these two and turn these two in to me before you leave. All you have to do, okay, for like the first one, here's our function v, here's our function v, and we want to plug in h of t. So it's just like on the very first slide where we had like f of 5. This was telling us to plug in 5 for every x value. So the same thing here. Okay, here's our function v. Now we want to plug in h of t in to every single x value of this function. Should be very straightforward. Don't worry about simplifying too much. Just write the function down on your own sheet of paper and then do something very similar, except this time actually evaluate the function h at 25. So you'll plug in 25 for each t, and then whatever your result is, plug into v. If you have any questions about this, feel free to ask, but please finish these two before you leave today and turn it into the basket. All right, thanks guys.